Hello, my name is Harmon Chabot. I am a pediatric intensivist at Presbyterian Hospital, and today we are going to continue our lecture series and really discuss ventilator modes, and more specifically SIMV. For the purposes of this lecture, we will be using the interface from the Puritan Bennett 980 series of ventilators, this just being the ventilators that we have available in our hospital. And what we'll do is we'll be basically honing in on the parameters that we dial in, and the list of these parameters is along the bottom of the ventilator screen right here. We are dealing with a neonatal patient, and so we'll really kind of cut through each one of these settings that pertains to our patient. Now, what are the components of the breath that we'll discuss? We will first start off with rate. The rate you can find next to this F. It's the first one that we set. And for this patient, the rate is set to 22 breaths per minute. The next one that we'll just kind of hop over to, I know we're going to skip over the PI for right now, but will be the TI. It's also known as the inspiratory time. And the inspiratory time is basically how long the patient is going to breathe in for. The next marker that we'll look at is basically the one that says P-sup right here. And this is in relation to pressure support breath. Essentially, once the patient starts breathing above the rate of 22 breaths per minute, this will be the parameter of pressure support that the patient will get for those breaths above that set rate. And then the next one we'll kind of look at just for right now will be the V-sense. And the V-sense is also known as flow sensitivity, and it's basically how much flow does the patient have to generate in order to tell the ventilator, hey, I'm trying to trigger a breath. Now, we'll start with the rate, and the rate kind of gives way to the rest of the parameters that we'll be looking at. So for our example here, our rate again is 22 breaths per minute. So we can look at this in two different examples. The first example will be a patient who has this rate set to 22, and this patient is paralyzed. So the patient is not contributing any effort towards breathing, and therefore every minute the patient will take 22 breaths. And those 22 breaths will follow the rest of these parameters that are set by the ventilator. The second example that we look at, though, will be a patient that has this rate set to 22 breaths per minute, but they're wide awake and they're breathing above that rate. Let's say they're breathing at a rate of 40. Well, the ventilator will ensure that the patient takes a minimum of 22 breaths in that minute. So that bare minimum will be met. But the breaths that are above and beyond that, which would be the 18 breaths, they will be determined by both patient and ventilator. So let's talk about those 22 mandatory breaths that the ventilator has to deliver, because that is its goal. Well, the ventilator will start initiating this breath once it senses the flow trigger of 0.3 liters per minute through the circuitry. So once a patient moves that 0.3 liters per minute through the circuit, the ventilator knows, hey, they're trying to breathe in, let me deliver the breath. So again, the mandatory breaths have to be met, and the ventilator will dictate how long the patient will breathe in for. So for these 22 breaths, the patient will get 0.7 seconds of I time. That means it'll take 0.7 seconds for that breath to go into the patient. And then the ventilator will also dictate what that peak pressure will be for those 22 breaths. And the way that it dictates that is by this inspiratory pressure that's been dialed here of 20. So this inspiratory pressure is on top of the end expiratory pressure of 8. So 20 plus 8 gives us a peak pressure for this patient of 28 centimeters of water. But this patient is breathing above that, and about 18 breaths above that as well. So for those, it'll still trigger the breath the same way. Once it senses that 0.3 liters per minute of airflow has moved through the circuit, it'll trigger a breath. But these extra breaths, these 18 breaths that we're talking about, will be a little bit different. These are called pressure supported breaths. And for the pressure supported breaths, the patient will dictate how long they will breathe in for. So that I time isn't set by the ventilator. For pressure supported breaths, the patient dictates their own I time. But the ventilator will dictate what the peak pressure for this patient will be, because it'll provide 16 centimeters of water pressure on top of the 8 centimeters of water pressure, which is at the end of exhalation, giving us 16 plus 8 or 24 centimeters as a peak pressure on the ventilator for pressure supported breaths. So when we analyze all 40 breaths per minute, 22 of these breaths will have a set peak pressure of 28 centimeters of water. They'll have a set I time of 0.7 seconds. But those breaths that are above and beyond the 22 that are set by the ventilator, those 18 breaths that we talked about, those will have a peak pressure of 24 centimeters of water, but the patient can determine how long they want to take that breath in. They can take a quick breath in, or they can take a nice long deep breath in. That's their determination to make. The ventilator is to synchronize the delivery of these breaths once it meets that goal of 0.3 liters per minute of flow through the circuit. And so is synchronized intermittent mandatory ventilation, also known as SIMV. The one thing that I can't emphasize enough is that this takes time to get a good grasp on. So the more you can repeat this, the more you can try to think through this at the bedside, the better it's going to be. If there are any questions or concerns, we would be happy to talk about it. And I do encourage you to look at the next video as well, where we talk about assist control ventilation, and really comparing the two will give you a good understanding of this one. Thank you for your time.